Hello and welcome to Project 7 of my series of Arduino board video tutorials. This one's titled DC Motor. You probably are familiar with DC motors, especially if you have worked with other electronic projects such as robotics. And the DC motor that you used in that project is same as the DC motor that we'll use here. This DC motor is just it's a little smaller, but the operating principle is the same. So now, because we are creating a circuit, it's going to be helpful for you to understand how a DC motor works. So that way, when when it's time to explain the other components in the circuit, it clarifies things a little bit more. So basically, the DC motor, and if you look at our schematic here, this is our DC motor. DC motors work off of what's called the induction process. Let me do this. All right. And what that is well, first there are coils of copper wire that run um, inside of the DC motor. And when current is running, we'll send current through the DC motor. Current will be flowing through these coils of copper wire, and what will happen is they will generate a magnetic field. And when that magnetic field is generated, what will happen is it will cause the um, metal shaft that's inside of the motor. The shaft is what you attach the wheel or propeller to, but it will cause the metal shaft will rotate. Okay? And that's basically how DC motors work. DC motors are typically used in applications where it has to move an electric vehicle such as a robot, um, or propel, like hoist, lift something very like with a significant amount of weight. And in order for that DC motor to operate effectively, it's going to require quite a bit of power. Now, as far as the DC motor that we'll be using in this project, the amount of current that we'll need in order for it to function effectively is about 300 milliamps of current. So this, let me do this. 300 milliamps of current. Now, what comes out of the Arduino board is about 40 milliamps. So it's like, how do we get from 40 milliamps to 300? Well, that's this device here. This device here is transistor. And what this transistor basically is, it's like an amplifier. Yeah. So what'll happen is it'll amplify the current that's coming to it to a usable amount by the DC motor, um, to well within the 300 milliamp range. And the transistor operates in a switch-like fashion. So it's either on or it's off. So if there's no current right here, this is what's called the base here. The B stands for base. And that's where um, the signal will come in, or the current will come from the signal. And when it does that, it creates a connection between these 2 points here, which is your emitter, and this part here, which is the collector. Okay? And then it causes the current to flow. If there's no voltage being supplied to the base of the transmitter operates in a switch-like fashion and shuts off. And then nothing, the DC motor won't work. With this being the first time we've used a transistor in our circuit, I wanted to give you a little bit of an insight as to what its function is and how it operates. As you can see, transistors are very useful, and they can be found in every type of electronic device around us. Now this component over here is a diode, and it serves as a one-way street for electricity. So it'll only allow voltage to flow in one direction. And the reason that we need this component is because the DC motor can generate its own voltage as it spins. That voltage created by the DC motor is sometimes referred to as reverse voltage or back voltage. So with this diode here, notice that it's wired in parallel with our motor. It'll prevent any of that back voltage from traveling back through our circuit and damaging any of the other components in our circuit. And if you notice, we have a push button switch in our circuit. So what'll happen is we push the button, the DC motor will spin. We release the button, the DC motor will stop spinning. We also have a 10K ohm resistor over here connected to the output pin of our push button switch and going to ground, so that way when the switch is released, then the reading on pin 2 of the Arduino is at 0 volts. That is basically it, as far as the overview of this project. So let's go ahead and start gathering the components to build the circuit.